Venkat. I'd like to know if there are questions. We have time for about 2 questions, I think. Yes?
Well, hello. I'd like to present myself. I am Ricardo Pontes. I'm a professor at the Federal University of São Paulo. I teach basically simulation and process projects. And actually, I will have 2 questions for you, Professor. And first, I would like to compliment on the very enlightening presentation that you just gave us.
Thank you.
Okay. First question. You mentioned that we chemical engineers sometimes we have the curiosity to question results given by a computer, by AI. Okay. And I see this as a trend for those above 40. Maybe not the new generation. How do we, as professors, as educators, can still, on this new era of AI, instigate students, new engineers, to always question those solutions? Okay. Second question I would like is...
Can I answer the first question first?
Sure, sure, then I will.
By the time you ask your second question, I might forget what you asked first.
Sorry.
That's a very good question, and in fact, I myself teach design and control. I taught that at Purdue, and I teach at Columbia. And I see that kind of behavior all the time. People would come to me with a distillation column that's 500 feet tall. And I asked them, do you think this is reasonable? They would say, no, this is what Aspen said, And so your point is, absolutely important, that there is a tendency to accept whatever the computer gives as gospel, and not question it. And that is something we really, as professors, as educators, we really need to drill this down, that you really have to ask whether this makes sense and why this is the result. And in that sense, we should encourage our people to make back of the envelope, analysis and estimates about what it should look like, so that we can understand whether the computer is making the right recommendation or not. And I think there is a tendency to believe in the computer a lot more, certainly among the younger people, because, in their experiences, generally speaking, whatever the computer recommended seemed to make sense in day-to-day experiences. And that might be okay, but in engineering, the cost of a mistake is very high. So this is what I tell my students and my children, that when Rotten Tomatoes makes a movie recommendation and you see it and you are not happy about the movie, it's okay, you wasted 2 hours, maybe $10. So the cost of a mistake there is low. But if it makes a recommendation with respect to process safety in process control applications, and you get it wrong, the cost of the mistake in a chemical plant can be very high. And so that makes AI systems a lot more suspect. It's one thing to use AI for hotel recommendations and TripAdvisor and so on. It's an entirely different game when it comes to design control optimization and safety in chemical plants, where you really need to know why that recommendation was made and whether that we should question those recommendations, because the cost of a mistake can be very high. So I share your concern about this, and it is important for us as professors to instill this kind of thinking in the younger students we teach.
Thank you. And this brings me also to the second question, okay? And you see, you brought to us information and trends that more and more decision-making will be done by AI, or at least not decision making, but choices given to those who have to make decisions.
Right.
And as a former project engineer, my concern is that some of these students, okay, I'm not criticizing all of them, okay, but some of them might be maybe 10 years from now, skipping maybe in a project, FEL 1, FEL 2, going straight to basic design without giving too much thought on conceptual design. And this is where you lose all that money, okay, because you just accept everything on the computer. And my question is, how do we, as users of artificial intelligence, let's take some of the responsibility given to AI and say, this has to be decided by humans still. This cannot be skipped, and this will take some time to do. Like, we shouldn't let still some computer make a decision which free technologies might be used to produce a certain product.
Right,
okay?
right.
I don't know if you understood my question.
Let me answer the way I understood it. Okay. And it is related to your first point, isn't it? It's, that is, whether we should trust computer advice blindly. And as people rely more and more on AI for these decisions, they will be losing these skills themselves. And then when it comes to a critical point, they may not have the experience that is needed to address those things, whether it is in design, as you pointed out, the design options, or even in operations when the alarms go off. And it is not clear, at least in my mind, where to draw that line. I mean, like you said, there should be some sort of a demarcation between for what things we depend on the computer as the responsible agent, and then for what things we depend on the humans. I think we will learn all that in the next 20 years as these things become more and more widely used. We make our mistakes and then hopefully learn from those failures. And but keeping an eye open that there is this possibility that there are certain things. In my mind, I mean, next 30 years, at least in chemical engineering, in process systems engineering, humans are not going to go away. The problems are so complicated, and the human presence will be needed. We will get a lot of assistance. These AI systems, in my mind, will serve as smart assistants, but the ultimate decision-making authority will still stay with the humans, and the responsibility also should stay with the humans for the foreseeable future. Too much reliance on computers can be problematic at this stage. We are not there yet. And a case in point is what we saw with the Boeing MAX accidents, right? So that was computer control failure, and then, in fact, it's a failure in design, I would argue. This one particular sensor was largely deciding whether whether the plane was stalling or not. And you can see there the trade-off between efficiency and robustness. As you drive our systems to be more and more efficient, there is a cost to be paid. Even though you're saving money, clearly, by increasing the efficiency, the cost will be paid in the robustness. That your system will not be as robust as it could be. So at some point, we have to, it is related to your question about where to draw the line. It is the same trade-off between efficiency and robustness. Robust systems would require fairly active human involvement, even though it is costly in the short term, but it actually is safe, it saves money in the long run. For example, now Boeing is going to pay billions of dollars for these 2 accidents that happened. Sure, they saved money with these more efficient design in the short term, but there is a cost in the long term if you if you make that, if you cross the line too far to the other side. Both questions are very difficult questions to answer.